Hello, this is the luckiest maths teacher in the world. Today we're looking at the unit circle, which is a way to extend trigonometry beyond angles that are between 0 and 90 degrees. But before we do that, we're going to have a quick review of exact ratios. So let's say I have a right angle triangle like this that is isosceles. So because it's isosceles, this angle here is 45 degrees, and so is this angle here 45 degrees. So these two sides, this side and this side, they are both the same. So I can call this side whatever I want, this side here whatever I want. The other side is the same, so I'm going to say this is 1 and this will also be 1. So by Pythagoras' theorem, this side here will be the square root of 2, which is approximately 1.41. So from this I can come up with some exact values. In other words, I'm not going to use decimal numbers to evaluate these. So cos of 45, it doesn't matter whether you use this 45-degree angle or that, is the adjacent over the hypotenuse. Sine 45 is the same. It is opposite over hypotenuse. It doesn't matter which one you use. Tan 45 is going to be opposite over adjacent, so it's 1 over 1. Now, I can get some more exact values from a special type of right-angled triangle where the hypotenuse is double the shorter side. So let's say I have a triangle like this. So this is my shorter side here again. I'm going to call it 1. I could have called it any number, but that wouldn't change the results that I'm going to get. So if this is 1 and the hypotenuse is double that, so 2 units, then by Pythagoras, this one here will be the square root of 3 units. So I've got my right angle. When this happens, it turns out that this angle here is exactly half of this angle here. So this angle here would be 60 degrees and the other angle 30. It has to be because they have to add up to 180. So I can see that sine 30 is opposite over hypotenuse. But this is also the same as cos 60, which is adjacent over hypotenuse. So sine 30 equals cos 60 equals a half. I can see that sine of 60, so this angle here is opposite over hypotenuse, so it's the square root of 3 on 2, which is about 0.87. But that's also the same as cos 30, because cos 30 is adjacent over hypotenuse. I can also get exact values for tan. So tan 30 would equal opposite over adjacent, so it's 1 over square root of 3. And then tan 60 would be this angle here. It would be opposite over adjacent, so it would just be the square root of 3. So these are exact values, and I'm going to use these in the unit circle. So what actually is the unit circle? Well, let's draw up a circle of radius 1, centre at the origin in the Cartesian plane. You know how to graph these circles. You've seen them before. So this is actually the graph of x squared plus y squared equals 1. So it's a circle of radius 1, and you've seen these before. So what I want to do is I want to be able to find the sine, cos, or tan of any angle up to 360 degrees, because there's 360 degrees in a circle. So what I'm going to do is I'm going to find the sine, cos, or tan of an angle, and that angle is going to be made with the positive x-axis, which is this one here. So let's say, for example, I know from my exact values that if I draw a triangle here, right angle triangle, I know that if I say that this angle here is, say, 30 degrees, I know that this length here is 1 because it's the radius of the circle. I know that the sine of that angle is 30 degrees, a half. But see, the thing is that in this right angle triangle, I can just call this length from here, the origin to here, x, because it's whatever the x coordinate is of this point that I've just marked. Similarly, I can call the distance from here to here y, because that distance is whatever the y coordinate of that point is. So I have, using my normal sine, cos, or tan, that cos of whatever the angle is there, in this case 30, is just the value of x, whatever that value is, because it's adjacent over hypotenuse, x divided by 1. Similarly, I know that sine of whatever that angle is, whether it wasn't 30, it could be 20, 50, whatever, is just whatever the y value is, because it's opposite over hypotenuse, y over 1. The tan of that is going to be the opposite over the adjacent. Or in other words, it's going to be sine of that angle divided cos of that angle, because of opposite over adjacent. So I know that cos 30, for example, is the square root of 3 on 2. I know that sine 30 is a half. So I'm saying that this point here, if the angle there is 30, this point here will be, so the x coordinate is going to be square root of 3 on 2, and the y coordinate is going to be a half. So sine of 30 is the y value, which is a half, and cos of 30 is the x value, which is square root of 3 on 2. So I haven't really told you much new, but what I'm going to do is I'm going to show you how we can figure out, say, the sine or cos of a larger angle. So let's say I wanted to find sine or cos of 150. So as I said before, I'm always looking at the angle it makes with the positive x-axis. So if I want a 150-degree angle, it's going to go like this. I'm going to have a triangle that goes down there, sorry. Now, this angle here in there would be 30, because it needs 30 more to get to 180. I make a triangle like that. Now, the green triangle and the red triangle that you see there, they are actually congruent. The reason that they're congruent is because they both have a right angle, so there's a right angle here and there. They both have another angle, the same. They also have the hypotenuse, the same, because the hypotenuse of this green triangle is also 1 because it's the radius of the circle. So they are congruent by the test AAS, 2 angles on one side equal. So what that means is that in this triangle here, the green triangle, this here will have the same distance as over here. The y coordinate, how far we've gone up, will be the same. It will also be a half, and the distance here will be the same as in the previous triangle, root 3 on 2, which is about 0.86 or 87. So if I want to find the sine of 150, I'm finding the sine or cos of this angle here. But I told you that sine is just whatever the y coordinate is. So this angle here is 150 degrees. So sine of 150 degrees is just going to be whatever the y value is here, which is a half. The y value here is positive because it's above the x-axis. If I want to find the cos of 150 degrees, so here the distance is the same. Cos is the x value, but here the x value is negative, so it's got the same number as it did before, root 3 on 2, but this time it's negative. And I can find the tan of 150, and that is just sine 150 divide cos 150, and because it's a positive divided by a negative, it will be negative. So tan 150 will be negative 1 on root 3. So what we can see is we now have a way to find sine, cos, or tan of angles that are more than 90 degrees. Previously, we've only looked at right-angled triangles where you couldn't have an angle more than 90 degrees. But now we have a way to do that. So let's go look at a few examples. So let's say I wanted to look at the value of sine of 210, for example. So we need to give this some sort of meaning. What I do is I start at the positive x-axis and I find an equivalent angle in the first quadrant, and then I decide on the sign, no pun intended, the sign there I mean positive or negative, okay? So I'm going to start here and call this 0 degrees, then I'll be 90 degrees, 180 degrees, and 270 degrees. Now, remember that sine of whatever angle I'm interested in is the y-coordinate, cos of the angle is the x-coordinate, tan of the angle is going to be y-coordinate divide x-coordinate. So over in this quadrant here, all of sine, cos, and tan are positive because the x values are positive, like 1, 2, 3, and the y values are positive too. So I'm going to put an A there, meaning all sine, cos, and tan are positive. Over here, the y value is positive in this quadrant, but the x value is negative. So cos is negative, sine is positive, but as we just saw, because sine is positive and x, which is cos, is positive, tan will be negative because it's positive divide negative. So only sine is positive in this quadrant. The y value is positive, but the x value is not. Down here in this third quadrant, x and y are both negative. So tan will be a negative divided negative, so it will be positive. But sine and cos will be negative, so only tan is positive in this quadrant. And in the final quadrant, as you can probably guess, only cos is positive because the x value is positive in this quadrant, but the y-coordinate is not positive. So the way people usually remember this is starting at the first quadrant and going anti-clockwise. All students take calculus or something like that. Come up with your own way. So if I want to find sine 210, this is what I do. I start here at 0, and I need to go all the way around 210. So if I go from here to here, I've got 90, 180, and I need to go a further 30 degrees. So I'm going to draw a triangle like this, and this angle here is going to be 30 degrees, because then that means that this whole angle, starting from the positive x-axis and going anti-clockwise, that whole angle in black is 210. So to find sine of 210, it's a bit tricky. I don't know what to do. What I do, though, is I look at the first quadrant and I draw a congruent triangle. So I'm going to draw one here that's 30 degrees. So I know that in the first quadrant, if I have 30 degrees and a right-angled triangle like this, like the one that's on your screen, I know that sine 30 is equal to a half. We went through that before. I know that the y-coordinate of this point is a half. So sine 30 equals a half. Because this triangle here and this triangle here are congruent, corresponding sides of congruent triangle, this distance and this distance must be the same. So sine 210 is going to have the same y value, this distance here and this distance here, it's going to have the same y value, so it's also going to be a half, but in the third quadrant, only tan is positive, sine is negative, because the y-coordinate is negative, it's below the x-axis. So sine 210 is going to be negative a half. I'm going to do one more example. So let's say I now want to figure out what would be the value of cos of 300 degrees. So I start at the positive x-axis and I go anti-clockwise, so I go 90, 180, 270, and I need a further 30 degrees to go here. So I'm going to draw my triangle like this. This angle here is 30, but I want the angle it makes with the x-axis. So of course this angle here must be 60 because they're complementary angles. So I have no idea what could cos of 300 actually be. So it's cos of this angle in black here, 300 degrees. So because I'm stuck, I'm going to draw a triangle in the first quadrant and I'm going to make them congruent. So if I draw a triangle that goes like this, and this angle here also has to be 60 degrees, then I know that because they're congruent, of course, this side being common, they both have the exact same x value. And remember, cos of whatever the angle we're interested in is just the x value. So this distance in red is going to be the value of cos 60, but also the value of cos 300. But that's really awesome because I know that the value of cos 60, we did the exact ratios before. I know that that's also a half. So cos 300 is going to be equal to a half. Now remember we're in the fourth quadrant, so cos is positive in the fourth quadrant. So my answer, is it going to be positive half or is it going to be negative a half? It's going to be positive because the x value is positive here. So this is how we define and find out the sine, cos or tan of angles more than 90 degrees, whereas previously we couldn't. I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.